Welcome back to the Unity Crash Course. Last time we did a very quick introduction to the Unity editor, and today I said that we would talk about scripting. Scripts. Unity uses C# as its scripting language. Maybe you haven't used C# before, but if you're comfortable with C++, you're going to find C# is a very easy translation. In the previous video, I mentioned that every asset you use within your project must be somewhere underneath the assets folder. And that is true of scripts as well. So I like to make a little scripts folder, and as it develops, maybe I'll make subfolders and organize things. Unity lets you be very flexible with your organization of assets as long as it's under the assets folder. So let's create our first C# script. We will just right-click here in the folder that we want to be in. I'm going to be in the scripts folder. Let's right-click and create a C# script. And what shall we call it? Let's call it my first script. Now you don't have to put the extension on it. You'll see right down here, Unity has already put the extension on it for you. When we select the script, over in the inspector, we do see the script has already been created for us there, but that's not a good place to edit. We're not going to be able to edit in the inspector tab for this. We'll want an actual script editor, or at least a text editor. You can use any text editor that you want to edit these. They are just text files, but I'm going to recommend you actually use Visual Studio for this. I've set up Unity to use Visual Studio as my script editor. So when I double click on a script, it will automatically open it in Visual Studio. So I guess what we should do first is make sure you have set up your Visual Studio as well. Back in the Unity Hub, we have the ability to manage our installs. And I am in 2021.3.0, that's this one. And if I look down here, I can look at the modules that I have installed. And when I installed this, I installed it together with the Microsoft Visual Studio Community 2019 add-on. So let's make sure you've added that module. If you haven't added the module yet, close down your Unity, add that module, and I think that should leave you pretty much good to go. But wait, you say, I already have Visual Studio. I don't want to download it again. I just want to set up Unity to use it. Sure, we can do that. Let's get to Edit, Preferences, and External Tools. Under External Tools, we can choose the script editor here, External Script Editor. You could just use Notepad if you want. Let's set it to your chosen Visual Studio. And next, we're going to want to not just use it as a raw text editor. You saw there Notepad was an option. Any text editor will do, but we want a true IDE, something that will let us debug and see symbols and show errors and stuff like that. So we're going to need to go to the Package Manager window. So Window Package Manager, and it takes a minute to open all the features. We're going to need the Visual Studio Code Editor package. Editing mat here, there are two options that you see there, and I referred to Visual Studio Code, although I'm actually using Visual Studio. Visual Studio offers two different editors. One's called Visual Studio Code, one's called Visual Studio. I actually recommend go ahead and grab the Visual Studio one. In the video here, I'm going to talk about using the Visual Studio Code one, but the one you actually want is Visual Studio. If you're using Visual Studio Code, that's fine too. Use the Visual Studio Code module instead, but I'm only going to support within the class the Visual Studio module, not Visual Studio Code. Okay, back to it. If you do not already have that installed, you're going to want to add that. If you don't see it in the list, you need to go to the Unity registry, and then you can use the search tab, Visual Studio. Want to do it? There you go, Visual Studio Code Editor, and you're going to want to add that. If you've never used C# before, you'll see that it does look sort of similar to a C++ program. We have a class, And in that class, there are class functions. You can see that. You can also create variables inside the class, just like you do in C++. The differences here are subtle. We'll go over them as we go. You'll see that this class inherits from a base class called monoBehavior. And in C++, you would normally put the word public there. We do not in C#. Also, in C++, you'd expect to see pound includes up here. Instead, just see usings. Usings are not exactly pound includes. They're like using namespace in C++. In C++, I strongly discourage using statements, but in C#, we embrace them. Unity's template has filled us in with two blank starter functions. We have a start function and an update function, and it even tells us what they're for. We're going to put this script and attach it to an object, one of the objects within our scene, and when that object is first created, the start function will be called. And as the function is updated each frame, the update function will be called. So let's start with our hello world type of project. Let's just print something out to the console. So we will print with debug.log, and I'll just print start there. And in the update, let's do debug.log update. Okay, let's just start with that and we'll see what happens. We've saved the file and we come back here. When you see down in this little corner, you see the little spinny that appeared there. That means it was recompiling. It's now recompiled and we're ready to go. The problem is I haven't put this script anywhere into my scene yet. Scripts are associated with game objects. Now the list of game objects is here. So let's put the script on my stick person. I can just drag it right on there and drop it. And now if I use the inspector, I can see that my script is on that object. I mentioned before that Unity uses a component system. So each of these scripts is a unique component, and you can hang as many components as you want on an object. You can even put multiple copies of the same script on the object if you want. I don't want to, so let's remove all but this one. Okay, let's run the game. I'm now going to show you the next feature, which I haven't covered yet. Right up here, we see a play button, a pause button. This is called Play in Editor. I'm in the editor and I'm going to begin playing the game. So I'm going to play the game right here in the editor. I don't have to make a build. I can just play it right here in the editor. And sure enough, hey, the game's working. What about that script? What about that printout that I said I was going to do? That's going to go to the console window. Here's the console tab right here. And you can see that I've gotten the start printed out and the update also printed out. But look what's happening over here. The update is ticking up a number. What's going on with that? If you look at the console options, there's a collapse option and it is currently selected. So if we turn that off, we'll see what's really happening is that the update print is coming out to the console over and over and over and over again. And what collapse does is it just takes all the text that matches exactly and it just collapses those into one line instead of repeating it 30,000 times for you. Now, before I go any further, some of you maybe haven't taken any game-specific classes before. And so let me run some of the just basics of games past you. The way a game works is a frame at a time. We update a frame and then we draw that frame. And then we move on to the next frame and we draw the next frame. So a frame update would typically begin with collect your inputs, like are the buttons being pressed, is the mouse moved, collect your inputs, and then take whatever actions you're going to do, move the objects around, create new objects, destroy old objects, and then we will draw that scene. We'll draw that frame. Now that frame is complete. We'll move to the next frame. And we do this rapidly. We do that fast enough, we create the illusion of smooth motion. That's how it works. And so that's why you'll see this update function be called over and over. It's going to be called every 60th of a second. So 60 times per second, our update function will be called, and that allows us to do that, reading the inputs and moving the objects around. That's where we'll do that. Okay, so let's move an object around. What do? Let's just have it slide back and forth on the screen. This update is going to be called over and over. And so if I want a different answer for the update, each frame, I need some state information. I need something that remembers what we've done before. So let's create a variable within the function of type float. I like to use a convention of putting an m underscore. And I'm going to call it timer. And I'm going to initialize that variable to 0. The m underscore signifies member. That's a member variable, just so that I can differentiate that immediately just by looking from local variables. Okay, so in my update, what am I going to do? I'm going to say m timer plus equals 1. So I'm going to count up 1 time unit every time update is called. Okay, and then what am I going to do with that? I want the position of the object to move back and forth in a sine wave based on that timer. So let's say, let's do float pos x equals math_f.sine. I want the sine function, and those you find those in the math floating point, I think is what that f stands for, of m timer. Now that's going to be in radians, and I'm going 1 radian at a time. That's much too fast. Let's make it some fraction of a radian. 1/10 of a radian, so I've got 100th of a radian. 0.01 f times. I just need to put that onto my character. How do I move the character around? Every game object has something called the transform. Let's look at that again in the editor. We have a transform, and that's what we want to move. We want to move, let's say the x, which is this red, we want to move that value right there. So that's what we're going to want to get hold of. So that'll be transform dot position. And transform dot position should give us back a vector 3. So I'm going to get the character's current position, and now I'm going to say pos.x equals posx, and then I want to then update the transform to this new position. So I will just say transform.position equals pos. Okay, and now there's something a little weird about how this works. Let's take a look at this position here. Unity has used getters and setters extensively, and so position, although it looks like a variable, is actually a function. I am invoking the getter and the setter there, which this is why you cannot do, you might think you could do this simply and just say transform.position.x equals posx. Can't do that because this is a getter or a setter, and you can't access the individual elements that way. So that's why you do need to create a temporary, if you want to do some fiddling like that, so that you can then use the complete setter to put that in. Okay, let's test that out. I'm going to save it and go back to the game. We do the compiling, and we'll see the little compiling spinner there. And now, when we play in editor, let's see if our object is moving. There we go. There we go. The object is moving back and forth as promised. I just made up this speed here as 0.01 of a radian. And now let's try and imagine, what if I was working with the designer? A designer would probably not think in terms of fractions of radians per frame. It's like, what kind of a unit is that? And they would want the ability to tweak that value. Say, oh, I want faster, I want slower. So what would the frequency, what would be a reasonable way of describing frequency? How about oscillations per second, right? Okay, so let's say that. I want, we'll call it like, just call it frequency, but let's try to be more specific, like laps per second. I could say oscillations per second, but I don't know if oscillations is a friendly word. Let's say laps per second, maybe. Okay, hopefully that makes sense. A lap, back and forth. Okay, loops per second. Let's call it loops per second. Okay, so loops per second. Okay, let me just do, I'm gonna make a temporary float angle equals m timer times something. So there are 60, I said, frames per second. Now that's in seconds. Let's put this in seconds. Seconds, there you go. And so the angle, let's say loops. Loops is m loops per second times the number of seconds. So that's how many loops we've done so far. And now I need to convert that into an angle. Float angle equals, and there's 2 pi radians per loop, right? So mathf, does that have a 2 pi in it? Pi, it has a pi times 2.0 times loops. Okay, so that's the angle, and then let's put this right here. Okay, so if I want to speed it up, I can increase this number. If I want to slow it down, I can decrease that number. And here's one of the magic parts of Unity and the editor, is if you make this public, Unity will automatically expose that value in the editor. Let's go and see that. Here we go. Loops per second is exposed in the editor now. Let's hit play. Okay, that's going way too fast. What's going on? Obviously, we're running faster than 60 frames per second. I just assumed we were running 60 frames per second. But that's not a good assumption to make. Instead, and if you're new to games, this will be new to you. Each update, we need to know how much time there is between updates so that we can do things like can calculate how many seconds we're at right now. And that is available to us in time dot. We have a lot of values here in the time class, and one of them is delta time. Delta time is how much time has elapsed between this frame and the frame that came before. So now the timer is now counting in seconds. So that's in seconds, and now that should allow us to accommodate different frame rates, particularly different frame rates in different situations and maybe even different platforms. Maybe it runs super fast on a PC like we just saw. Maybe it doesn't run quite so fast on a phone. So we need a system that can adapt to different rates of play, and that's how we accomplish that with Time.deltaTime. We'll be using that a lot. Let's see it now. We should see 1 loop per second. 1, 2, 1, 2. Okay, and as we saw, the loops per second, we exposed it so that the designers can tweak it, and the designers can say, hey, that looks good. You know what, but I want it faster. I want it to go 2 loops per second. No, I want 10 loops per second. No, I don't. I want 0.1 loops per second. And as you can see, I can edit it right there, and it immediately takes effect while I'm playing. So I'm going to leave it here at 0.1 loops per second. Watch what happens though. Warning, watch what happens when I turn off play mode. Boom, it went back to 1. All of my changes that I made during play mode are not saved. The theory here with Unity is that during play mode you can make tweaks, you can experiment, but they are considered an experiment. You can do whatever you want and be fairly confident that you're not going to mess things up if you're tweaking those values during play mode. What you want to do is mostly tweak them around until you like them, and then when you've chosen one that you like, then you turn off play mode and enter that value. I'm going to save this scene so that that is stored forevermore, and now when I run it, we'll see it's going to launch with the 0.1 on there. Let's do basic input. Let's make a new variable, float move. I'm going to default it to 0. Now I'm going to say if input dot, and you can see I got get key down. There's good guesses. I want get key returns true while the user holds down. So yes, get key, and key code is what I put here. Key code dot, and I want A. Key code A, if the user is holding key code A, move.x minus equals 1. And then we'll put if input dot get key, key code dot D, move.x plus equals 1. Oops, that's not move.x, it's just move. Made it a float. Okay, and so move now is a float that's -1 to the left, +1 to the right, and if I press both A and D, the -1 and the +1 will cancel each other out and go back to 0. All right, that'll be my motion now instead of this loop. So let's do something a little bit different. Let's say we're going to start with the character's current transform. I'm going to say toss toss.x plus equals move times, I'm going to want to tweak here for this. How fast do I go? Let's lose these. We don't want those anymore. And let's make a new one. Public float m move speed equals, I'm going to say 1. And that's going to be in units per second. So how do I convert from units per second into like what I need for this? I need to know how many seconds have elapsed. So how many seconds have elapsed on this frame? That is time.deltaTime. There you go. We're going to use that time.deltaTime again. All right, and then we put that new position into the transform, and let's give that a go. So what have we just introduced here? The input class where we have a get key and a key code. This is how we ask, are you currently holding down the A key? This is how we ask, are you currently holding down the D key? Very simple and straightforward. And then we are using delta time again to modulate how fast we move. Let's give this a go. All right, I'm going to hit the A key and let go. I'm going to hit the D key and let go. I'm going to hit them both. I'm going to hit A and then D and then let go of A and then back to both and then back to A. There you go. Only it's just super slow. Let's crank it up. Let's crank that up. There you go. How's that? There you go. We're practically made a game here. Practically made a game. Okay, let's sum up. The first thing that we did was we set up Visual Studio as our script editor. And then we created a script using the right-click Create C# Script menu. And we have done a little bit of editing with that. We've seen that the update function is called over and over every frame of the game, and we use that to update our various characters and components within the game. We have created some variables, member variables in our class, and we showed that the public variables are exposed out here in the editor for the designers to tweak. And that's how we will let them control and refine the behavior of our game. Either we'll do that ourselves, or we can give this to other people then to play with and say, hey, I set up the Stickman component. I tweaked it to where I like it. But if you want them a little faster, you want them a little slower, just adjust that variable and then hit save, and you've saved the scene all ready to go. And we also saw that we can use Time.deltaTime to control how fast things move. We use that to determine how long an update is. So that does it for scripting. At least for now, we'll be doing a lot of scripting in this class, so we'll be back to it and you'll get plenty of practice with that.